Hello everybody, my name is Dubar Villalobos, taking a master's in data science, and this is basically the result of the Kaggle competition for the advanced regression techniques in terms of determining home prices. I will explain below is basically what I did in order for me to try to solve the problem of trying to predict the prices based on certain variables that are given. So from here, basically, I'm going to go to the modeling part. As you know, we have a total of 81 different variables to play with. I basically took the time to look at one by one. It took a lot of time, but basically, after analyzing some of the data and some of the things that the variables basically had on them, I realized that some of them had not really available information, and some of them had some sort of duplicate information in terms of family related variables, like for example variables related to the basement, to the bath, to the fireplace, to the garage, and some other variables that I considered that could be explained by other ones, avoiding some sort of noise due to excessive variables. I did some cleaning in order to remove these duplicate or non-valuable information variables. After I did perform the cleaning, I was able to reduce from 81 to 57 different variables. After that, I basically wanted to see how the categorical variables were playing in terms of trying to predict the values with them. Since I cannot do any analysis with categorical variables, I did a transformation to numerical. So I basically transform all the categorical variables into numerical values. It took a lot of time, since remember these were 57 variables and I had to look at them one by one and trying to figure what the best values were in terms of assignments in order to try to play with the data a little bit better. After I finish, after a long time, basically all the variables, as you can see, ended up with numerical values or int, and this is basically what I wanted. From there, I wanted to treat my trained data set as 80% training and 20% test. So I split my data set in two. From there, I try to perform some correlations, and from the 57 variables I ended up with this plot over here in which the red color is a negative and the blue color is a positive correlation. I basically stick with the positives. I think those are somehow related for the price, and as you can see, we got some positive and negative correlations from the sale price in terms of the other variables. What I did was basically to take the ones that were over 0.25 in the positive side. I consider those to be some sort of moderate or have some sort of moderate correlation to it. I ended up with 21 variables out of the 57. So basically by now I've been able to eliminate about 60 different variables for my linear model. After I did all that, I started doing my linear model from there. Basically what I did is to take the 21 variables and then do backward elimination. The first model, actually I was quite impressed. A median of 1001, an R-square of 0.8171, and a p-value of very small, which is below 0.05, the threshold that we always most likely look at. Also, I see some p-values over here that are quite small, some of them not so, or not too much. So what I ended up basically was taking them off one by one and then comparing. So in this case I took out the garage finish and then I noticed that the values stayed about the same. The median increased in this case, farther away from 0, and I kept doing it for quite a few other variables until I thought that I had a pretty good model in terms of p-values, in terms of the r-square, and in terms of the median. Now, this is not really 0 or very near to 0. However, I'm looking at the data in the thousands and hundreds of thousands, so I thought like 242 is not actually bad. Could be improved, probably, but I wanted to keep going since I had some really good values in terms of p-values and a very good r-square over here, with an adjusted r-square not too far away from it. So I basically kept doing. I noticed that the residual standard error was quite high, but I wanted to see how this was going to look. So the first linear model is basically this one that I just presented. However, when I did plot the fitted values versus the residuals, I noticed that it has some sort of quadratic shape and not necessarily a linear line around 0. Also, I noticed that the values are a little bit high. When I plot the quantile to quantile plot, I noticed that there are some outliers, and also not necessarily this data follows a normal distribution, but the majority actually fit pretty good along the line, so I kept going. Another thing that I did was basically to test with the training test 20% data that I split it before, and I noticed that the minimum was about 9,682. The median was about what the data actually has, and the mean is not pretty bad compared to the data from the training set. The delta, I got a little bit surprised with those values, are a little bit off. However, the median is not bad, not too off from 0. And my confidence interval within 95% is from 175 to 192,000 with a mean of 183,000. My p-value was actually pretty good. But once again, I was a little bit disappointed by seeing those big differences in between from 0 deviating for the delta, so I was not happy. So I kept going, and then I did a run on the test data to see what's gonna happen. I found out that the test data had some missing values that the training data set did not have, so I had to adjust that, so it took extra time. And after that, I noticed that the minimum value in the test data, there is a negative. So I got quite disappointed by looking at these values over here that are below 0. It's like if you're gonna go and buy a house, but actually instead of you paying, you're getting paid. It's not a bad deal if you ask me. However, it's not what really happens. And when I did the comparison in between the predicted versus the training data set, I found out that there is quite a lot of difference on the extremes, especially in the minimum on the lower side, and a little bit over the higher side. However, the median and the mean are not too far apart. So, and my confidence interval with a 95% on the t-test basically is from 174,000 to 181,000 with a mean of 177,000. And that's basically it. When I submitted my submission to the Kaggle competition, I got a score of 0.45, and I'm not very happy with that. I think it can be improved, but since this is the first time, I took it as a learning experience in terms of all the process that has to be taken for the training, and you cannot forget about the data set because you have to take extra time looking at the test in order for the linear model or the model you actually put to work to consider all the missing values on the test or the final production. So that's my learning experience. Thanks.